So previous, this is a what? Practice of standing waves. We already did some practice in the previous class, previous part. Now this is part 2 of standing waves. Okay. So now explain, they said in cinema, sounds normally comes from number of speakers. In the cinema, you have different speakers, okay, placed at different position around the room. Explain how the sound waves travels through the air. 3 marks. If they ever ask you regarding the sound waves, 3 points are absolutely necessary in your answer. What is it? You have to mention vibration. You have to mention longitudinal waves. You have to mention what? Compression and rarefaction. এই তিন কনসেপ্টটা যেন তিনটা কনসেপ্ট থাকে মতন ভাইব্রেশনের কনসেপ্ট লংগিটিউডনাল কনসেপ্ট কম্প্রেশন আর রেফ্র্যাকশনের কনসেপ্টটা যেন থাকে মতন you have to combine these 3 keywords and write your answer for 3 marks. Okay, otherwise you are not going to get answer this thing over here marks. Okay, so how do you frame it? Let's see the mark scheme. But remember, if they talk about how sound waves are formed, 3 things are more than necessary. What is it? Unit, uh, longitudinal waves, unit, compression and rarefaction, unit, what? The vibration of air particles, right? Okay, regions, you have to use the word regions of compression and rarefaction. Okay, this is June 2017 IEL question 15. I think same paper if I'm not wrong. June 2017 IEL, yeah, same paper. Same mark. Let's go to question number 15. Okay, so check what is the answer they wrote over here. Just check it. What are the answer they wrote here? Longitudinal waves are creating series of compressions and rarefactions, oscillations, vibration parallel to the direction of travel, blah blah blah. Oh, parallel to the direction of travel. My bad, my bad. So oscillation, vibration of air particles. Understood? 2 points. Then you have to also use the word. You have to use the definition of longitudinal waves. Online, everyone understood these 3 points?
Yes.
Akira, Sujata, Salma. Hello.
Yes.
Okay, fine. Then let's go to the next one. What a listener here depends on the position of the source of the sound. Okay, so that day we did this. I think one of this question. I don't know. Was it us or was it someone else? Maybe it was the other the ones who are giving qualifying. They I think did similar question in the latest paper also it comes. So the diagram shows source of sound when it is placed in front of the listener to the left of the and to the left of the listener. So you have a your sound box in front of you like this, and if it is like this over here, okay. And all of you guys are aware of diffraction here, right? Everyone knows about the diffraction concept. Do I have to explain diffraction? Because as long as I remember, I think I did not explain diffraction to you guys till now. So you guys are supposed to know that diffraction takes place is that when your when the gap, okay, I think you can use the word aperture also, when the gap, okay, is equal to the wavelength, when the gap is equal or less than wavelength, significant diffraction takes place. This is how diffraction, if they tell you to draw the diffraction, you need to draw a straight line like this, and from the center you need to draw these arrows, but with the help of rulers. Without this, here also you have to show the direction. This is the proper diagram of a diffraction. Understood? This is a proper, I think I already said you this in O level as well. This is a proper diagram of diffraction. Diffraction, what happens when your wavelength is greater than or equal to, okay, size. Okay. If the gap is too high, like for example in this one right now, same diagram, but if the gap is too high, let's say this is my gap, you see the gap is more than the wavelength, so in this case your waves will not get diffracted, so no diffraction takes place. Online people, understood? It's that when your gap is equal to or less than, okay, when the gap is equal to or less than wavelength, significant, the word significant diffraction takes place. Online everyone understood the concept of diffraction? It's getting recorded anyway.
Yes.
The sound waves from the source in front of the listener arrive each year at the same time. So definitely you know it is getting diffracted here. Okay. The sound waves from the source to the left of the listener arrives at left ear first, and the sound waves then reaches the right ear by diffraction. Okay. Describe how the sound reaches the right ear by diffraction. Okay, we have to know this. How diffraction. You have to, I think, definitely you have to write about key, wavelength and all, and aperture or the size of the gap. I think you have to use the word aperture over here. Okay, diffraction takes place. Khalas, that's it. How the sound reaches the right ear by diffraction. Yeah, you have to talk about the aperture and the wavelength size. That's it. Okay, let's see the mark scheme. Which year is this? Which one is the same, na? Yes, same. Question number 15. Let's see the mark scheme. Spreading of waves when going around the head listener, obstacle. You have to use the word obstacle. Okay, you have to use spreading of waves because they already use the word diffraction over there. So you have to use the word what? Spreading of waves when there is an obstacle. And so please write this thing down. Diffraction is the spreading of wave. You write this down actually. Diffraction is the spreading of wave when there is when there is an obstacle. Spreading of waves when there is an obstacle. Okay. Then full stop. You write. You write diffraction takes place. Diffraction takes place when the size of the obstacle is equal or less than the wavelength. When the size of the obstacle is equal or less than the wavelength. Done? Is it done? Okay, fine then. So next they're asking about the intensity. Okay, okay. This is the intensity of sound heard by the ear in the power per unit area reaching the ear. Okay, you know what is intensity? Like how much sound per meter square is reaching. Yeah. Particular source of sound is placed on the left side of the listener, left of the listener. The graph shows how intensity of the sound reaching uh, each ear varies over range of frequencies. Okay, so you can see the for left ear it is same all the time, doesn't matter. The left ear the intensity of sound is constant. For right ear it's dropping as the frequency is increasing. Okay, it's dropping. Why? Explain the difference in the intensities. 5 marks. Okay, you know, I'll pause the video. Let me discuss the answers with you all. Okay, so we discussed the answer. Let's see what is the actual answer. Intensity reaching the left ear is same, constant for all frequencies. I said that line. Right ear intensity is less than the left ear intensity when sound has traveled further energy. Okay, sound has been reflected or absorbed by the head. Okay, maybe Amarta hobe na because I don't have hair. But you guys, most probably, if you guys have bouncy hairs, yes, why not? It will get absorbed. Yeah, it can. The sound can be absorbed by the hair a bit. Okay, okay. Intensity reaching the right ear decreases. Okay, because higher frequencies are diffracted less. We already discussed all these answers. Everyone online, did you guys understand? You see, just look at the mark scheme and look at the question they asked you. Look at this mark scheme. Just read the answer. Then I will show you the questions again. Read the answers, please. Okay, now look at the question. What did they say? Explain the differences. But before explaining the differences, you need to explain the graph also, na? Because they did not say what is happening in the graph. Did they explain the graph over here? No. You have to interpret the graph. Then you have to interpret why is it happening to the graph. Online people, সবাই বুঝছো কিনা বলো?
Yes.
Okay then. Okay. Fine. Let's go to the next one now. This one. Tuning fork one, na? Cool. Now, a tuning fork is used to produce sound of single frequency. Yesterday, that day I showed you in the video, I think. Ding! Like that. It produces a sound like if you hit it with a hammer. Ding! Like that. Now, the tuning fork consists of two metal prongs joined at one end. Okay. When the fork is struck against a surface, the prongs vibrate and the note is audible. Audible means you can hear it. You guys know from 20 hertz to 20,000 hertz is audible frequency. In O level, we did that. Do you guys remember that? 20 hertz to 20,000
Yeah.
audible. After that, it is ultrasound. Yes. Okay. When the fork is held close to the ear, explain how. I'm not even doing this. I'm skipping it. Everybody knows it. Okay. So fine. Let's continue. I feel tired. Now, student holds a vibrating tuning fork gently against the surface of ball of water. A pattern was observed. Explain the pattern observed. Okay. This I can explain with the help of constructive and destructive interference. I'm going to do this later on. It's a 6-mark question. This is all about phase, antiphase. Antiphase, then constructive, destructive, maximum, minimum, zero amplitude, maximum amplitude. Eta otai 6 mark 4 mark hai. Very easy to do. I'll explain this later on to you guys, don't worry. Okay. Okay. Lower frequency, state the difference that we observed. This I'm going to do later on. Okay, this is what I want to do with you guys. Fine. Very important question. Okay, a sound is created by blowing across the top of a tube which is open at one end. The sound is recorded and displayed on a graph, amplitude against frequency. Fine then, let's continue. So you have this amplitude against frequency, sound created blowing cross tube. Tube er moddhe. You know what is a tube, na? Is it an open tube or closed tube? Did they mention that? So this is opened at one end. So it's a closed end tube. Open and closed end tube eta. Dono the same night. So now you can see this is, I'm pretty sure দেখো মাঝখানে কোনো frequency নাই, amplitude নাই, এখানে amplitude বেশি বাড়ে গেছে, মানে এটা হচ্ছে first fundamental frequency সেদিন শিখেছি। This is your second fundamental frequency and this is your third fundamental frequency. Okay, basically this is first harmonic motion frequency. This is the frequency for first harmonic motion, this is the frequency for second harmonic motion, and this is the frequency for third harmonic motion. Online people, everyone understood? Okay. ওকে দেখো এখানে ওরা দিয়ে দিছে ফার্স্ট হারমোনিক মোশন, তোমাকে ডায়াগ্রাম দিয়েও দিছে। এটা একটা অ্যান্টিনোড, একটা অ্যান্টিনোড থাকলে কি হয়, this was the down one. No, you don't have first harmonic, you have first, you have third, and you have fifth. Sorry, I forgot. Several frequencies of the sounds are observed. Each frequency corresponded to a different standing waves in the future. Sorry, the standing waves in the tube. The loudest মানে যার amplitude সবচেয়ে বেশি ওটা loud বেশি, এটা প্লিজ মনে রাখো, ও লেভেলে পড়ছিলাম আমরা এটা, that the energy or the if you put if you hit a drum, the amplitude is going to be very high of the drum. If you hit it with more energy, sound ও বেশি আসে। তো যেটা sound loud হবে ওটার amplitude ও বেশি হবে। অনেকে ভাবে frequency মানে loud, no, frequency means how thin that voice is, or how, I will not say they use the word fat, but how broad the voice is. There is a difference, na? ওটা মানে amplitude না, amplitude মানে this is amplitude. এটা কম amplitude, কম amplitude. High amplitude. You guys are getting the hang of it, what I'm trying to say? Yeah. Okay. Chalo then, there is nothing to laugh. Okay, now. Several frequencies of the sound are observed. Each frequencies correspond to different standing waves. The loudest is 410 hertz. So this is 410 for us, most probably. Okay, they gave it to us 410 hertz. ঠিক আছে. Now remember, isn't L was lambda by 4 over here? Okay, let's see. Now this is the diagram of nodes and antinode. কেন open tube এর মধ্যে সবসময় একটা antinode থাকে? We know that, na? Open. Okay. Explain how standing waves is formed. We know this. I'm not even saying you. Now, add to the diagram to show the standing wave pattern for an overtone and state its frequency. Overtone. Overtone মানে কি জানো? Fundamental frequency কথা বলতেছে। Overtone. So, is this 410? Yes, this is 410. That shows standing wave created at the fundamental frequency. Okay, antinode. And what is overtone, by the way? Yes, the higher frequencies observed are known as overtone. So this is one of the overtone over here. Okay, let's say how many lines are here from this point to this point? Oh, so sorry, this is going to be third fundamental frequency. How does the third fundamental frequency look like? I showed you guys last time. Money basically second fundamental frequency, but we call it third fundamental frequency, right? How does it look like? Two antinodes and two nodes.
Yes.
Are you sure about that?
Yes.
Okay, chalo then. So let's see this. Let's draw this. Let us draw from here. আমরা এখান থেকে এখানে তো একটা নোড থাকবে, এখানে গিয়ে ওটা অ্যান্টি নোড হবে, আবার এখানে গিয়ে অ্যান্টি নোড হবে, এরকম। নো, ওয়েট, একটা অ্যান্টি নোড, এটা এরকম, এখান থেকে আসবে এরকম। আন্ডারস্টুড ইউ গাইস? দিস ইজ দ্য ওভারটোন, ওয়ান অফ দ্য ওভারটোন। আমরা চাইলে এটাও ড্র করতে পারবো, বাই দ্য ওয়ে। We can draw the third one also, but I'm not doing the third one. I'm doing the, sorry, I'm not doing fifth one. My bad. I'm saying again, this is F0. This is 3F0. And this is 5F0. Remember that. Okay. So, and if they tell you to find the L, this is going to be L is equal to lambda by 4. This is equal to L is equal to 3 lambda by 4. This is L is equal to 5 lambda by 4. এগুলো বাহার করতে হবে, গতবার করাইছিলাম আমি এগুলো সব। ঠিক আছে, সবাই তো মনে আছে না? সো দিস ডায়াগ্রাম ইজ কমপ্লিট। তোমাদেরকে এটা লেবেল করতে হবে। দিস ইজ অ্যান্টিনোড, সরি দিস ইজ নোড, মাই ব্যাড, নোড, অ্যান্টিনোড, নোড, অ্যান্টিনোড। Everybody clear with this diagram? 3 marks. In mark scheme you are saying they wrote na na. You can see that over here. Wait, let me show you. Which year is this? It's a new this thing, na? This is October 2000, June 2016 GCE. June 2016 GCE. This is Ashok na bhai, amar ki. June 2016 GCE. Let's see physics paper. June 2016 GCE. Guys, please, we are doing some story here. Hi now, how are you? Is on good though? Question number 7. 7 or 17 is it? 17. Okay. It's IL GCE. What happened? GCE. My bad. GCE. They wrote June 2016 here. I wrote June 2016. I don't have any GCE paper. Oh, I opened Jan 2016. June 2016 GCE. Koto? Question number? 17. Okay, so they wrote over here. See what to draw? Nana, which we did. Otherwise, you can also draw na na na. What do you mean by node, antinode, node, antinode? N stands for nodes, A stands for antinode. Fine, everyone? No, because first এটা ওটা already draw করে দিয়েছে আমাকে। First one, because first এর পরে যারা আছে, this is the fundamental frequency. এর পরে যারা আছে এরা সবাই overtones. They are what? Overtones. That's what they said us here in the question to draw overtone. Read the question. Understood? Okay, fine then. Let's continue now. Now, carbon dioxide is poured into the tube and sound of the standing waves for the tube is recorded again. Now, now they put carbon dioxide over there inside the tube. Now, what happened? Their frequency decreased a bit. Can you see? I think the frequency shifted a bit towards the left. The frequencies seen are lower than with the air. So in carbon dioxide, the fundamental frequencies, harmonic motions are coming in lesser frequency comparatively. You can see that over here. Now they're saying determine the value of the speed of the sound in carbon dioxide. Now, speed of the sound. Okay. Do we know the length of the tube? We know the length of the tube. Okay. Let's talk about this one now. How much is this, by the way? Let's find it. How much is this? Okay. How many lines are over here? 5, 10, 15, and 20 lines. 20 lines, how much? 500, right? 20 lines, there are 500 hertz. Yeah. Now, how much is this? 5, 10, 11, 12, 13, 14, 15 lines, right? 15 lines are going to be how many hertz? So cross multiply it. 500 into 15 divided by 20. 375 hertz is my frequency over here. So I got my frequency. 4 marks. Okay, 375 hertz I got. No, they want speed from me. V is equal to F lambda. I got my F. I need lambda. I got lambda for first overtone is what? L by 4. Lambda by 4. L is equal to lambda by 4. L is equal to lambda by 4. So L koto 20.3 divided by 100 is equal to lambda by 4. So 20.3 divided by 100 into 4 karo. What is the lambda you guys are getting? 0.812 meter. You have the lambda, you have the frequency, find the velocity for me. Let me pause the video. Do that on your own. Oh yeah, I did record this and I said you guys to do this on your own. Now, what is the answer you guys are getting? 304.5. Let's see the mark scale. Yeah. So 305 meter per second. Done. Online. Everyone got this now. It is done. They will ask you these kind of questions as well. Now, okay, you guys try to do this one on your own. Objective questions. Yalla. Pause video. So so you can see this question. It's an open antinode on each end. Which of the following correspond to the wavelength lowest possible frequency? If I remember, it's 2L by N is equal to lambda for both the sides open. So it is 2L. Lambda will be wavelength na 2L. So C should be your answer. Online, everyone. Understood? Hello?
Yes.
Let's continue now. Now, we will now start doing this. Question number 6 and 7 is related. Okay. You guys do start doing this. This is a stationary wave. Which one is correct over here? Who can guess? This will not take much time.
B.
D maybe.
Oh, no, no. A. No, no, no.
D. C.
अच्छा
C.
একজন বলছে ডি কোনটা ফাইনালি বলো আমাকে সি
C correct.
C.
বিকজ ওরা একটা অ্যান্টিনোড কে লেবেল করতে পারবে না সবগুলি নোডই এখানে অ্যান্টিনোড কে লেবেল করেই নাই ওরা ঠিক আছে ফাইন দেন এসি অফ করতে হবে স্টপ করে ফাইন নাও স্টার্ট ডুইং দিস কোশ্চেন নাম্বার 7 the length of the string is 4 meter what is the wavelength of the stationary wave wavelength of the stationary wave এখানে কত দিছে এটা একটাই wavelength না এখানে okay what did they say the length of the string is 4 and what kind of fundamental frequency is this what kind of harmonic motion is it second harmonic motion so what will a lambda is equal to L lambda be L only na because lambda is 2L by 2 2 get cancelled so lambda is 4 C is your answer 7C now Now anybody needs an explanation why it is 7C? Hello?
Yeah, explain it too.
Explain. তুমি নিজে দেখতেছো এই গ্রাফটা, তোমরা নিজে দেখছো এই গ্রাফটা কি সেকেন্ড ফান্ডামেন্টাল ফ্রিকোয়েন্সি। Can you see this? Because there are two antinodes are here. So
Yes.
fundamental frequency lambda formula ki lambda is equal to 2L by n. Cancel. Lambda is L. So what's the length of the string? 4. So your lambda will also be 4. So therefore C is your answer. Is this understood?
Yeah.
না এটা তো স্প্রিং এর, এটা টিউব থেকে না, এটা কোনো পাইপ না, এটা স্প্রিং। See they said over here, it's a guitar string if I'm not wrong, of a string. ঠিক আছে? কেন তুমি মেহেক বুঝতেছো এগুলো সব সামগুলো?
Yeah.
Fine then. Okay, let me pause the video. So now this is the last two questions that is left. So they gave us a diagram of open and closed tube, and they gave, and question number 6 they asked which one is true. So this is wrong, this is correct most probably. The antinodes are the position of maximum amplitude, and that is true. Antinodes are position of maximum amplitude, nobody can. So B is your answer. Understood everyone? You understood? Okay, now this one, they said the length of the pipe is 0.75, find the wavelength. Now if you see this diagram and if you remember my previous class properly, we know this is of 3f0, right? This is 3f0. So 3f0, the lambda formula is what? Wait, let me pause the recording. Acha ji. So this is another part of standing waves, but it's a new concept. We call it sonometer. Now, before showing what this thing, before teaching you what sonometer is, let me teach you guys how does the sonometer looks like. Acha guys, just give me 2 minutes. I need to talk something to my brother. So let me show you guys how does a sonometer looks like. First of all, how does a sonometer looks like? I can say, okay, it's a box. On top of the box you have strings, and you plug the string and it produces a sound. That is a very minimalistic explanation I can give you, but let me show you guys how does a sonometer looks like. Okay, so let me pause the video, then let me search it in YouTube. By the way, okay, we are going to see now what sonometer is all about, but you don't need all the complicated explanation in this video. We don't need that. Okay, just how does it look like, where the strings are, how the strings are tightened, bas egulo dekhle hocche amader jonno. Okay, so let's see those.
Using sonometer. Materials required for sonometer.
Let's see.
Tuning forks of
So you have tuning forks. Okay,
different frequencies. Weight hanger with weights.
okay, you hang this so that you can make the string tight or loose, like that by hanging it. Okay,
Rubber hammer and steel wire. Sonometer consists of a hollow rectangular wooden.
can you see this box? Can you see that pulley? Can you guys see the string? Online people, you guys are getting hang of it? Online people? Sujata, Salma, Panna, Marwa,
Yes.
guys, বুঝতেছো? Okay,
Box
Yes.
with for free vibration. A meter scale is fixed at two sides of the wooden
এগুলোকে আমি
box.
এগুলোর নামটা আমি তোমাদেরকে পরে বলবো। এই জিনিসগুলো, এই দুইটা জিনিস এখন যেটা দেখছো, I call it clamp. And you have meter rulers over here, okay, to measure the length.
1 meter length of string is fixed to one end and passes through two movable bridges.
Okay, you can also call it bridges. Yes, and these bridges you can move them right and left if you want to. These bridges, the one which you see right now, you can move them right and left if you want to.
B1 and B2. A frictionless pulley is fixed at the edge of the box. The weights are hanged at the other end of the string. Here, a paper error is placed at
Okay, we don't need much. How does the sonometer looks like? Idea to chole asche tomader. And you guys saw my diagram as well, na? You guys saw the diagram which I did. It is a perfect, na? Ekdam perfect diagram. I hope. I know it doesn't justify this thing, but whatever. Let's go to. So you guys see this diagram? It gives you a very common idea what's happening over here. Okay. Now what do we do with sonometer? Why do we need sonometer for? So today let's do the learning. Next class we'll do the solving part. Not next class, 8 to 10. 8 to 10 we're going to do the solving part. No, today 8 to 10. We will be finished done by this today itself. Okay. The principle of string instruments can be shown using a sonometer. One of the principle of string instruments is guitar and all, right? When string is plucked, if you pluck over here, ting, ting, you're going to get some sounds over there, na? When using strings is plucked at midpoint, the waves gets reflected, and so what I was saying that the waves gets reflected and standing waves are formed. Can you see this bridge over here? I call it bridge and clamp both, right? I named it clamp over here. We can also call it what? Bridge. Okay, so if I pluck it, you see that waves is going to reflect and come back. It's going to form a standing wave over here. Yeah. With the help of this instrument, we can actually measure three relationship. Okay, yesterday was Valentine's Day. Okay, we can measure three relationship. What is it? How is tension related to the frequency? How is the length of the string related to the frequency? And how does the thickness of the string related to the frequency of the sound produced? These three relationship I can find. How is the tension? How is the frequency related to tension? Like basically, তোমার তারটা যদি tight হয়, অথবা or if it is loose, tight হোক অথবা loose হোক, it doesn't matter. ফ্রিকোয়েন্সিটা কিরকম differ করে, okay, ওটার উপর depend করছে. Now, so you can see what they wrote. The frequency of the sound can be obtained by using a microphone. What do they do? I am recording. I am recording. So once when you're going to pluck it, what will you do? You're going to take a microphone and you're going to connect the microphone to an oscilloscope. And this oscilloscope will give you the frequency of the sound. Understood? The oscilloscope will give you the frequency of the sound. So what you can do is you can hang weight after weight, and each time you pluck it, okay, and you're going to see the changes in frequency in your oscilloscope. Then what can you do? You can make a table. What table? One is tension, another one is frequency. Then you can draw a graph. Understood? Now let me say these things in detail to you. They're saying that the frequency of the sound can be obtained by using a microphone connected to cathode ray oscilloscope, or you can say CRO oscilloscope. CRO, cathode ray oscilloscope. The relationship between frequency and the length of the string, frequency and length of the string can be found by shifting the clamp. Okay, here I say tension and frequency. Let's first of all learn frequency and this thing. Length of the string, frequency and length of the string. Somebody came? Okay, wait. Okay, I'm starting. So now what they will do for different length of the string? How will they how each time I have to change the length of the string? No. If you want a short length, bring this bridge over here. If you want a short length, bring the bridge over here. Measure it with the help of meter ruler. Okay. If you want a longer length, bring the bridge over here. Measure it with the meter ruler. If you want more length, bring the bridge over here. Measure it with the meter ruler. So for each length of the string, what is the frequency you can hear? Basically, what is the frequency you get the reading from the oscilloscope? You note it down. So you're going to draw a table of length and frequency of the sound, length of the string and frequency of the sound. So if you draw a graph, frequency of the sound produced by the range of different length of the wire is noted down. You guys are getting the point now? Then you will draw a graph. What graph is it? F versus 1 by L or F versus L. You can see the frequency is inversely proportional to length. Frequency is inversely proportional to length. This means that if the length is longer, the frequency is lower. If the length is shorter, the frequency is higher. Understood? Everyone online got this experiment? How this experiment is done by using sonometer? Everyone? There are two graphs you're supposed to by heart. Online. Done? Yes, don't by heart.
Yes.
এটা হচ্ছে f versus 1 by l, আরটা হচ্ছে f versus l. মেহেক বুঝছো? সালমা, সুজাতা?
Yeah.
সুজাতা, সরি সুজাতা নেই, সালমা,
Yes.
মেহেক বুঝছো?
Yeah.
Okay. Now, relationship between frequency and the tension. You saw that big this black color hanging thing over there. You saw now. So that one is used to increase the tension. This part, that hook part they use. Okay. How? Oh, my diagram is perfect. Okay, now. Okay, now. Relationship between frequency and the tension in the string can also be what? Determined. Tension in the string can be changed by changing weight. Okay, by changing weight you can change the tension. তোমার নোটিস করছো না, একটা রাবার ব্যান্ড নাও, ওটাকে বেশি যদি টান দাও, what happens? And you start vibrating it. The frequency is going to be very high na. If the tension is high, frequency is also going to be high. How we are going to measure it? With the help of oscilloscope, microphone, and by plucking it. এখানে length constant থাকতে হবে। এখানে এখানে কি টেনশন কনস্ট্যান্ট থাকতে হবে, এখানে টেনশন কনস্ট্যান্ট, এখানে কি কনস্ট্যান্ট? লেন্থ কনস্ট্যান্ট থাকতে হবে। আর একটা জিনিস আছে, ওটা আমি পরে বলবো। Okay, so if you're doing the graph, this is the graph you guys are supposed to know. Frequency versus root of t, straight line from the origin, or frequency square versus t, straight line from the origin. Bhaiya, why not f and t? Why only f square and t and f and root of t? Why only this two? Why root? Why are not only f and only t? Why can't we do that? Why can't we do that? Depending on, because we should know this formula only. All this graph we are drawing is because of this formulas over here. Okay, there are two formulas which you guys are supposed to know. Let me draw it for you. No, let me write it down for you. These two formulas regarding the sonometer or any string related concept. Actually, string related concept, it's this. Let me just draw it. Okay, first thing first, you guys are supposed to know v is equal to root of t by mu. V is equal to root of t by mu. This is something you're supposed to know. What is mu? Mu means mass per unit length. Mu means mass per unit length. Or you know what, instead of writing like this, let me just write it. Mass per unit length. Understood everyone? Okay. So what is mass? Kg per meter. That's your unit. You know, what do you mean by that? What do you mean by that? For example, let me take a wire which looks like this. Let me take a wire which looks like this. Let me take a wire which looks like this. And let me take a wire which looks like this. Let's say they all are 1 meter. They all are what? 1 meter. Eta maybe 1 gram hobe. Eta maybe 3 gram hobe. Eta maybe 5 gram hobe every meter. This might be 1 kg. Who knows? So that's what we call mass per unit length. মানে 1 মিটারে কত কেজি? That is mu. ওই তারটা 1 মিটারে, this is not my this thing. Suddenly what did this mean? Everybody is here na? So suddenly what happened? Okay, so you understood na? All of you? Mu মানে হচ্ছে mass per unit length. আরেকটা ফর্মুলা তোমাদেরকে জানতে হবে is this, that the fundamental frequency equals to 1 by n. Okay, 1 by what? N by 2l, my bad. N by 2l. Fundamental frequency is equal to n by 2l into root of t by mu. I will now teach you how to derive this equation. I'll teach you guys how to derive it. I think this is given, but still, I don't think so. Physics se kyo even formula sheet pichone dekhe ho, like useless, because most of the question, this thing, equations, you guys use it so frequently, you have to just bahar them. That's it, because you're using it too much frequently. Pichone jete jete onek time lagbe. আচ্ছা whatever, আমাদের কাছে দুইটা ইকুয়েশন আছে এখন। এই ইকুয়েশনটা কিভাবে ডিরাইভ করে আমি তোমাদেরকে শেখাবো, ঠিক আছে? প্রথমে আমি তোমাদেরকে ইকুয়েশনটা ডিরাইভ করা শেখাচ্ছি, এদিকে দেখো সবাই। ওকে, ফার্স্ট you guys know v is equal to f lambda, right? Right, v is equal to f lambda. Okay, you know f is common constant over here and there is lambda. Okay, let's see now. If I'm talking about first fundamental frequency for a string, you know lambda is 12 by n, right? For a string lambda is 12 by n, you guys know that na? আচ্ছা, আমি v জায়গায় root of t by mu দিতে পারবো, f এর জায়গায় f টাই রাখবো আর lambda জায়গায় 12 by n দিতে পারবো। Is this understood? এখন আমি f কে সাবস্টিটিউট দ্য ফর্মুলা করব, I will cross multiply n divided by 12 into root of t by mu is equal to your fundamental frequency. সবাই এটা প্রুভ করা বুঝছো কিনা বলো? Everyone got this or not? How I derived to that equation over here? Everyone got it? কোনটা ডিভিশন হবে না? আরে এই n টা এখানে চলে গেছে, এই 12 টা নিচে চলে আসছে, cross multiplication. Understood? Understood or not? Okay, now it's because the root t is given to me here, that is the reason I'm drawing f versus root t graph, because আমার frequency সাথে root t সাথে কি আছে, connection আছে। Okay, if I'm talking about first fundamental frequency, if I'm talking about first fundamental frequency, then my formula will become 1 divided by 2l root of t by mu is equal to f1. f1 মানে হচ্ছে or f0 যাকে বলে আর কি, first fundamental frequency, because n is 1, that is the reason. Okay, so most of the time they give you this equation, but sometimes they put n over here, but 90% of the time they put 1 over there, because we always talk about only first fundamental frequency. That is the reason, and this is the reason I don't have any graph for f and t, I only have graph for f and root of t. Got it everyone? আচ্ছা, তো আমরা টেনশন আর ফ্রিকোয়েন্সি গ্রাফ কি বুঝে গেছি, লেন্থ আর ফ্রিকোয়েন্সি গ্রাফটি কি বুঝে গেছি। নাও লেট আস সি অ্যাবাউট দ্য মিউ। মিউ মানে হচ্ছে মাস পার ইউনিট লেন্থের রিলেশন কি ফ্রিকোয়েন্সির সাথে। ফ্রিকোয়েন্সির সাথে তিন জনের রিলেশন ফাইন্ড করতে হবে, লেন্থ, লেন্থ অফ দ্য স্ট্রিং, তারপর কি টেনশন ইন দ্য স্ট্রিং, তারপর মাস পার ইউনিট লেন্থ। এই মাস পার ইউনিট লেন্থটা কি জিনিস আমরা দেখিনি। It's written over here, yes, you can see that here. If you draw f versus root mu, okay, it's an inversely proportional. If you draw f versus 1 by root mu, okay, it's a straight line from the origin. Okay, so এটা তোমরা মনে রাখবে, এটা এটা এই ফাইলের মধ্যে আছে, সোনোমেটার ফাইলের মধ্যে আছে। এখানে একটা জিনিস দেওয়া আছে, some precautions. After this I'm leaving you guys, and 8 o'clock class আছে। The wire should be free from, should be of uniform cross section, and there should not be any bend or twist in it. So this is one of the precautions you guys are supposed to take. Then the pulley should rotate without friction. You guys know if there is friction it gets heated up, na? Therefore weight should not exceed the elastic limit of the wire. Okay, so if it exceeds the elastic limit of the wire, it does not return back to its original position. I will continue doing this sum, sorry, this page by the way, from next 8 to 10. Okay, so I can't tomorrow class over. Yalla guys, go and enjoy.